Hi, this is Dave Thomas. I'm the designer of the Automated Pass Evaluation System, or APES. And I made this video to try to help explain why sometimes good passes look bad. And it's all about camera angle, parallax, optical illusions, whatever you want to call them. They're really all the same thing. So what I'm going to do is take different views of different passes. Here we're looking at a 5-foot pass from quite far away. I'm going to go sit in the line judge chair. We'll see what it would look like from that view. So here we are. Familiar view. We have enough context where it looks perfectly okay to us. We'd probably call that a 5-foot pass. You might say a better view would be right straight over the start line. Let's say we put a camera, kind of like the apes do, we try to do, is put the camera right straight over the start line. What would it look like from there? We go overhead. We see the dog's nose is exactly lined up with the left edge of the wide stripe. I'm making that the start line in this case. And we look over here and we see our 5 pass lines, but the dog's nose doesn't seem to be lined up with that 5th mark. Well, that's due to camera angle or parallax. Parallax, one way to think of what that means is the rays, the light rays, not being parallel to each other. They actually converge, at the viewpoint. We could actually do something what's called a parallel projection, which is equivalent to viewing something from an infinite distance and then zooming up, in which case you don't have any parallax. And you'd see if we did a parallel projection, you would say, yeah, indeed, that dog's nose is lined up. Notice the difference between, now our start poles just look like little circles. We're looking right straight down on them, and it doesn't matter where, which one we look at. Our uprights look vertical. We don't see any of the front surface of it. Compare that to a perspective view. Here we're sitting 12 feet above the start line. We can see a little bit of the face of our jump over here. We can, when you see our poles, our start line poles, you actually see the sides of those. So that kind of shows you the difference. Just we anytime we're because of the foreshortening effect or perspective, we get these optical illusions. So let's start looking at something like a perfect pass, what it might look like. So here's an example where I got the camera sitting at 12 foot, dog's nose right on top the, just exactly a perfect pass. Now let's see what would happen. Instead of having the camera right straight over the pass line, we instead got a little sloppy when we put the cranes on top and we put it 2 feet on this side. If we look at that, we see, wow, it looks like that dog was, it looks like a bad pass. Clearly this dog broke the start line plane before the dog coming out did. Well, no, we didn't. It's the camera angle or the impact of parallax. Notice also that our poles don't look straight up and down. We'll go back and compare them before. Let's go back to where our camera was where it optimally should be. We see a little bit of this side of the poles, but we don't see any left to right slant of the poles. So that's a clue to whether the camera is going to give you an optical illusion or not. And similarly, we could, if we put the camera on the box side of the start line, we can get the opposite effect. That perfect pass, well, it didn't look all that perfect. It was, probably a 1-foot pass, you'd say, if you back this dog's nose up and try to play it back in time and say this dog was a foot away. So the point is depending on where the camera is, you can make the passes look quite different. So it's always going to be our goal to put the camera right straight over the start line. Now it doesn't have to be in the middle of the start line. If it's at the side, here we're going to put it right straight over one of the start poles. And we can tell we're right straight over because we can look right down it and we don't see any of the side of this pole at all. And we'll see, almost all the side of this other start pole, but we haven't slanted, we haven't created an illusion that would make us misjudge our passes. And again, the clue to that you've got a good camera angle is, you see this, the poles don't lean left or right. And comparing that to this, in this case, the camera, as you can see, the the bottom of the pole is farther left than the top of the pole. So that's another way of, the paint for the start lines is on the floor, and the dog's nose is a couple feet above the floor. So the the position of the start line looks farther left than what it really is. Is one way to think of it, just like the start pole's base looks farther left than its top, or vice versa if you've got the camera on the other side, like this. The other thing we should talk about, it's not parallax, but it can also fool you. The the shutters need to stay open on the camera for a non-zero amount of time, just to get sufficient light to expose the image. And that's especially true indoors without flash photography. We can't use flash photography because it'll bother the dog. So we have to have the shutter stay open for a significant period of time, a non-negligible amount of time. I use high gain on the cameras, make them very, very sensitive, so that time can be as low as possible, at the expense of some image quality, but it's still non-zero. So while that shutter's open, the dog actually moves. They continue to move a little bit. So the shutter, started to be open when the dog's nose hit the line, then continued to stay open until the dog's nose was a bit over the line. Also, the shutter doesn't open instantaneously. There is some delay from when that start line beam break is detected into where the shutter actually opens. We call that shutter lag. So here's an example what we might see. We got the camera right straight over the start line, but the dog's noses have, they moved a little bit, from when the start line beam was broken to when the image was actually acquired. So they call it nose overhang or what have you, but they both overlap the start line about the same amount, and assuming they are the same speed, you could back them both up and say, yeah, that was a perfect pass. You say, well, what if they're not the same speed? Well, there's going to be some error there. If the one was twice the speed as the other, then you might argue about, fractions of inches, but it's a good approximation to say that there's traveling, even a fast dog and a slow dog, you can pretty much back them up the same, and the error that you get is not really that large. But what you can do now is you start getting that same shutter lag with a camera angle that's non-optimum, and you can start getting things that look really bad. So here's our perfect pass with shutter lag, but our camera's 2 feet on the recall side, on the run back side of the pass line. You can see, wow, that pass looks really bad. Or on the other hand, we got that same shutter lag, and we have our camera on the box side of the start line, and you can say, wow, that was really not that tight of a pass at all. Anyway, I hope that helps you understand the impact of camera placement and shutter lag on the images that we acquire. I'm continuing to work on the actual shutter lag itself. We will evolve into improvements of that. It'll never be zero, but it should get small enough, I think, where we could get it down to certainly within the width of the start line itself.